Hi all. In this video, we can move on to module 2. So in module 2, main topics or the main cryptographic algorithm that we are discussed in module 2 are IDEA, AES and RC4. It is a stream cipher. Okay. These are the three cryptographic mechanisms that we are studying in module 2. IDEA, AES and RC4. So first we can study what is a block cipher and what is a stream cipher. You already studied about block cipher and stream cipher. In block cipher, what you have to do is you can divide the plain text into number of blocks and encrypt block by block. Okay, that is block ciphering mechanism. But in the case of stream cipher, what you have to do is you are taking sequences of bits or bytes to encipher or encrypt. Okay, so first algorithm in this module that we are studying is RC4 algorithm. It's a stream cipher. So stream cipher encrypts the plain text 1 byte or a 1 bit at a time. Usually we are using XOR operations with a pseudo random key stream. Okay, we are using a pseudo random key stream in the case of RC4 stream cipher. Okay, here the randomness of a stream key or key stream is completely destroys the statistical properties of a messages, or it completely changes the plain text. Okay, so here what we are doing is stream ciphering method. We have a plain text or message MI. We are taking 1 byte or a bit at a time, then XOR with some stream key that is generated by the pseudo random number generator. Okay, by performing this XOR operations, what we are getting is cipher text. Okay, you can see in figure there is a plain text 11001100. We have a key stream 0110110. What operation that we are doing here? It is the XOR operations for encrypting. Clear? By performing the XOR operations, we are getting an output that is the cipher text. Same way in decryptions, we have a cipher text. What we are getting after the encryption is the cipher text. Okay, that cipher text is the input of the decryption procedure. Okay, we have the same key stream. Then again, performing the XOR operations, what we are getting is the plain text. This is the procedure that we are doing in stream cipher mechanism, that is RC4 stream cipher mechanism. Clear? We have a plain text. We have a key stream, that is the key. Actually, this key stream is generated by the pseudo random number generator function. Okay, by using the plain text and key stream, we are performing XOR operations to get the cipher text. Okay, in decryption procedure, what we have to do is you have a cipher text, you are taking the same key stream, then performing XOR operation, then producing the original message or the plain text. Okay, so module 2 il nammal 3 basic cryptographic algorithm aanu padikkunnathu: IDEA, AES and RC4. The first one RC4. Adoru stream cipher mechanism aanu. Plain text 1 byte or 1 bit at a time എടുത്തിട്ടാണ് നമ്മൾ അതിനെ എൻക്രിപ്റ്റ് ചെയ്ത് സിഫർ അതിൻ്റെ കറസ്പോണ്ടിങ് സിഫർ പോർഷൻ ഉണ്ടാക്കുകയാണ് ചെയ്യുന്നത്. ഇവിടെ മെയിൻ ആയിട്ട് RC4ൽ പെർഫോം ചെയ്യുന്ന ഓപ്പറേഷൻ എന്ന് പറയുന്നത് XOR ഓപ്പറേഷനാണ്. സോ നമ്മുടെ കയ്യിലൊരു പ്ലെയിൻ ടെക്സ്റ്റ് ബൈറ്റ് ഉണ്ട്, അതിൻ്റെ കൂടെ നമ്മളൊരു സ്ട്രീം കീ ബൈറ്റ് XOR ചെയ്ത് കഴിഞ്ഞാലാണ് നമുക്ക് സൈഫർ ടെക്സ്റ്റ് ബൈറ്റ് കിട്ടുന്നത്. സെയിം പ്രൊസീജിയറാണ് ഏതിലും അപ്ലൈ ചെയ്തിരിക്കുന്നത്, ഡിക്രിപ്ഷൻ പ്രൊസീജിയറിലും അപ്ലൈ ചെയ്തിരിക്കുന്നത്. ഓക്കെ, സോ ദിസ് ഇസ് ദ ഫിഗർ ഓഫ് RC4 mechanism, okay, or how to generate a pseudo random stream key for the encryption of plain text into cipher text. So we are taking the original message as plain text. It's a byte stream M. Also we are taking another input key K. Okay, then key is inputting into the pseudo random byte generator, which will produce small k, that is the key stream. Okay, by using this key stream along with plain text byte stream XOR, then we are getting cipher text byte stream. Okay, this cipher text byte stream is the input of the decryption, right? Again, this cipher text is XOR with the key stream. What is actually key stream? Small k is the key stream, right? This key stream is coming from the pseudo random byte generator. Okay, and the input is key itself. Clear? So performing the XOR operation, that is the decryption procedure, then we will get a plain text. This is the basic method of R-cipher mechanism. Clear? So we have two inputs for the encryption procedure, a plain text and a key stream. XORing, that is the main function performing at the encryption end. Same way we have a cipher text and the key stream as inputs in the decryption procedure. We are performing same XOR operations to get a plain text. Then from where we get this key stream? By using the pseudo random byte generator, we are getting a key stream from the key. Okay, so this is the general structure of a stream cipher. Here key is the input to a pseudo random bit generator that produces apparently random key stream of bits which are XORed with message to encrypt it and XORed again to decrypt it by the receiver. Reception or receiver. Okay, this stream cipher is almost similar to one-time pack mechanism. So what are the design consideration for a stream cipher? How we can design a stream cipher? What are the rules? So for designing a stream cipher, first the encryption sequences should have a large period. So this large period means repetition. So the first design consideration for a stream cipher is the encryption sequences should have a large period. Longer that period of repeat means it's more difficult to do cryptanalysis. So that is the first design criteria for a stream cipher. That is here we are using a pseudo random number generator. So that uses a function that produces a deterministic stream of bits that continuously repeating. So larger the period, that means it's very difficult to do cryptanalysis. Clear? And the second one is what we are getting as output of the pseudo random generator is the key stream. That key stream should be approximately a random number. So if the output is a random number, without the knowledge of input, we can't do cryptanalysis. So that is the second design criteria. And the third one, the key needs to be sufficiently long. Why? Because it is very helpful to guard against brute force attack. Okay, if the key length is very high, then it is more difficult to do cryptanalysis like brute force attack. Okay, so these are all the design criteria or design considerations for a stream cipher. So stream cipher design criteria എന്തൊക്കെയാണ് ഡിസൈൻ റൂൾ എന്ന് പറയുന്നത്? ഒന്ന്, നമുക്ക് കീ ലെങ്ത് കൂടിയിരിക്കണം. ഇനി ഉണ്ടാക്കുന്ന കീ സ്ട്രീം എന്ന് പറയുന്നത് ഒരു പ്യുവർ ഒരു റാൻഡം നമ്പർ ആയിരിക്കണം. സോ അങ്ങനെ ഒരു ഔട്ട്പുട്ട് റാൻഡം നമ്പർ ആയിട്ട് നമുക്ക് കിട്ടുവാണെങ്കിൽ നമുക്ക് ഇൻപുട്ട് അറിയാതെ ഒരു എന്താ പറയുക ഡിക്രിപ്ഷൻ നമുക്ക് ചെയ്യാൻ പോസിബിൾ അല്ല. ഓക്കെ, ദീസ് ആർ ഓൾ ദ ഡിസൈൻ കൺസിഡറേഷൻ ഓർ ഡിസൈൻ ക്രൈറ്റീരിയ ഫോർ എ സ്ട്രീം സിഫർ. Next, we are moving on to RC4 algorithm. So RC4 algorithm is actually based on the stream cipher structure. Okay, and this RC4 algorithm, which is designed by the scientist Ron Rivest. He is a scientist of RSA structure also. RSA is a cryptographic algorithm and which is designed by Ron Rivest, Shamir and Edelman, 3 scientists. So for the one of the scientists of RSA algorithm is Ron Rivest. He himself designed the algorithm for algorithm as RC4. So it's a variable key size stream cipher with byte oriented operations other, and also this algorithm uses random permutation. Okay, and it is the most probably or most widely used stream cipher. So RC4, it is a stream cipher algorithm which is designed by Ron Rivest, the scientist. It is a variable key size stream cipher, not a fixed key size is there. It's a variable key size is used in the case of RC4. And also this algorithm is based on the random permutation. The main operation here is a permutation function, and it's a most widely used stream cipher. Also it's used in SSL bar TSL. It is a secure web protocol. Also we can use in WPA wireless LAN security protocols, etc. So these are all the main features of RC4. So RC4, it's a stream cipher designed by Ron Rivest. It's a variable key size algorithm. Also it uses a random permutation function. It is mainly used in TLS bar SSL protocol, also WPA protocols, etc. So here the RC4 key is used to form a random permutation of all 8-bit values. Also this RC4 generates a pseudo random number which is known as key stream. This is actually combined with the plain text by using XOR operation for encryption, and decryption is also processed in the same manner. As we already studied the structure of a stream cipher, the basic mechanism behind the stream cipher is also used in this RC4 algorithm, because RC4 algorithm is a stream cipher mechanism. That is, we have 2 inputs, one is the plain text and another one is the key stream. Okay, where we are getting this key stream? Key stream is the output of pseudo random generator which will take the input as the key. Okay, and by XORing this plain text with the key stream, we are getting the cipher text. And in the decryption procedure, what are the inputs? First one is the cipher text and the second one is the key stream, right? Again, there is a function known as pseudo random generator at the decryption side also. We get the output as key stream by using the input key as in the pseudo random number generator. Okay, so the decryption is also is the same manner with the is processed in same manner with the encryption. Okay, so this is the basic structure of this RC4. So we have a secret key, that is the capital K, right? We have the secret key and this will be the input to the RC4 algorithm, that is the pseudo random number generator algorithm. So we are getting key stream. Then by using the key stream, we can XOR with the plain text to produce the encrypted text or the cipher text. Cryptographically, this is very strong and easy to implement. Okay, so what is this RC4 algorithm? It has 2 parts. One is a key scheduling algorithm, another one is a pseudo random number generation. Okay, there are 2 parts for the RC4 algorithm. One is the key schedule algorithm. Then second one is pseudo random number generation algorithm. Okay. അപ്പോൾ നമ്മൾ സ്ട്രീം സിഫറിൻ്റെ ബേസിക് സ്ട്രക്ചർ പഠിച്ചു. സ്ട്രീം സിഫർ ബേസ് ചെയ്തിട്ടാണ് ഏത് അൽഗോരിതം വർക്ക് ചെയ്യുന്നത്? RC4 അൽഗോരിതം വർക്ക് ചെയ്യുന്നത്. അത് ഡിസൈൻ ചെയ്ത സയൻറ്റിസ്റ്റിൻ്റെ പേര് റോൺ റിവെസ്റ്റ് എന്നാണ്. മോസ്റ്റ് വൈഡ്ലി യൂസ്ഡ് സ്ട്രീം സിഫർ ആണ് RC4. അവിടെയും നമ്മൾ പെർഫോം ചെയ്യുന്ന സ്ട്രക്ചർ സ്ട്രീം സിഫറിൻ്റെ സ്ട്രക്ചർ തന്നെ വി ഹാവ് എ പ്ലെയിൻ ടെക്സ്റ്റ്, അതുപോലെ തന്നെ ഒരു കീ സ്ട്രീം ഉണ്ടാക്കുന്നു. ആ കീ സ്ട്രീമും പ്ലെയിൻ ടെക്സ്റ്റും എക്സോർ ചെയ്തിട്ടാണ് നമ്മൾ സൈഫർ ടെക്സ്റ്റ് പ്രൊഡ്യൂസ് ചെയ്യുന്നത്. ഇനി എവിടെ നിന്നാണ് ഈ കീ സ്ട്രീം കിട്ടുന്നത് ഈ ഒരു സ്യൂഡോ റാൻഡം നമ്പർ ജനറേറ്റർ ഫംഗ്ഷനിൽ നിന്നാണ്. സോ RC4 അൽഗോരിതം അവിടെയാണ് വർക്ക് ചെയ്യുന്നത്. അപ്പോൾ RC4 അൽഗോരിതം ഒരു സീക്രട്ട് കീനെ ഇൻപുട്ടായിട്ട് സ്വീകരിക്കും. അവിടെ രണ്ട് മെക്കാനിസം പെർഫോം ചെയ്യുന്നുണ്ട്. വൺ ഇസ് എ കീ ഷെഡ്യൂൾ അൽഗോരിതം, അതിനുശേഷം സ്യൂഡോ റാൻഡം നമ്പർ ജനറേറ്റർ. ഈ രണ്ട് അൽഗോരിതവും കൂടിച്ചേർന്നതാണ് നമ്മുടെ RC4 എന്ന് പറയുന്നത്. അത് പെർഫോം ചെയ്തതിന് ശേഷം what we are getting is key stream. Okay, so that key stream is XOR with plain text. Actually this RC4 algorithm is mainly used for generation of key, right? Key stream, not the generation of key. Key is actually the key stream, secret key. From that secret key what we are generating is the key stream. Okay, for the generation of key stream we are using an algorithm RC4. Okay, it has two parts. One is a key scheduling algorithm and another one is a pseudo random number generator algorithm. So key scheduling algorithm, first we start with an array of numbers from 1 to 250. So first we start with the array as S and the array numbers from 1 to 255. Okay, S actually forms the internal state of the cipher. Okay, what we are doing is, in key scheduling algorithm we are making a loop from I equal to 0 to 255. Then initialize S of I to I. Okay, to begin, the entries of S are set to equal to the values from 0 through 255 in an ascending order. That is S of 0 equal to 0, S of 1 equal to 1, up to S of 255 equal to 255. Okay, so that is the first initialization procedure. We are taking a state vector from 0 to 255 as the index. Then what values are inputting this array vector? 0 to 255 itself, right? Then we are taking making a temporary vector. We are taking a temporary vector as T. It is also created by using the equation that is K is the secret key, right? K of I mod key length. Okay, here the key length is 256. So K of 0 mod 256 is 0 itself, and in next iteration what it is, T of 1 is equal to K of 1 mod 256, that is equal to 1. So what we are getting as T is 0, 1, 2 up to 255. Clear? So that is T of 0 to T of 255 means K of 0 to K of 255. So actually what we are doing is we are copying the key values into a temporary vector. Okay, first we are initializing the state vector. Second case, we are copying the key value to a temporary vector. Then initialize j equal to 0. Okay, this is actually done for initial permutation of S. What is actually permutation? Rearranging. Okay, so for I equal to 0 to 255, do j equal to j plus S of I plus T of I mod 256. So first I equal to 0. Okay. Then what is the value of j? J equal to j plus, what is the initialized value of j? 0. So 0 plus S of 0 plus T of 0. What is the value of S of 0? Take that. What is the value of T of 0? Take that. Plus, then again plus with j equal to 0. Then what we are getting is the result. Then mod 256. That is actually j. Then at last, we are swapping the two values. Both values, S of I and S of j. So that is actually the permutation process. So for key scheduling algorithm, we have two parts. Initialization of state vector as well as the initial permutation. We are shuffling that state vectors. Okay. Or we are permuting that state vector. Clear? This is the first part of the RC4 algorithm. And in the case of second part, that is pseudo random number generator, we are actually generating the stream key or key stream by using some permutation function. After that, we are performing encryption, right? XORing the plain text with stream key. Okay. So for pseudo random generation, first we are initializing I and j value as 0. Then we are taking 1 byte of a plain text or some bytes of a message mi. Then we are doing two equations, that is I equal to I plus 1 mod 256 and j equal to j plus S of I mod 256. So by using these equations, we can get I value and j value for the first iteration. Okay. Then swap S of I and S of j. Then we have another equation, that is T is equal to S of I plus S of j mod 256. Okay. That T value SO is the index of the stream key. That is S of T is the stream key. Clear? Taking each byte of the message, by using the two equations, we are getting I and j value. Then swapping the S of I and S of j value. After that, we are getting the stream key index T as S of I plus S of j mod 256. That is the index value of the stream key. Then find out the S of T. S of T is the stream key. Okay. And XOR with the MI, message byte, to produce a cipher text. This is the encryption procedure. Pseudo random number generator plus the encryption procedure. Clear? So these are all about RC4 algorithm. Okay. By using some examples, you can also work out these two parts of the RC4 algorithm. So this is a stream cipher RC4 algorithm. Thank you.